We are on page 260 in lesson 19, where we are working with solving for exponential equations. And in this section, we are really combining all of our skills for solving equations and using logarithms, including logarithmic properties to help us solve. And on this page, we're looking at problem number 15. And what I did first, right off the bat, is I turned this into a logarithmic equation by logging both sides, as you can see here in red. I did a common log of 10 to the 3x minus 5 and a common log of 7 to the x power, which allowed me to use exponential properties, and that was specifically in this case the power property, bringing down the exponent 3x minus 5, because the product property, or excuse me, power property says that when you have an exponent of an argument, like this 3x minus 5 is raising 10 to the 3x minus 5 power, we could bring it down and turn it into a multiplication of the log of that argument. All right, so again, one more time, the product property allowed me to rewrite the left side, the power property, allowed me to rewrite the left side of this equation by bringing down the exponent 3x minus 5 and turning it into a multiplication problem with the log. Same thing can be done on the right side here. Since we have 7 to the x power, I can bring down that x and multiply it by log argument 7. Cool. Now, what I'm basically looking at this problem is I have a situation where I can start to work to isolate the x's one at a time. And the big thing that I'm going to do right off the bat is I am going to distribute 3x times log 10. So now we have 3x log 10, log argument 10, perhaps more accurately said, minus 5 times log 10. Again, this is all that I'm doing here, y'all. I'm executing the distributive property denoted with these green curves there on top. Awesome. And that's still equal to x times log 7. Keeping in mind at this point now, log 7 and log 10s, those are just numbers. We could evaluate those with the calculator. I'll say that to the end though. So now what I really have the ability to do is start to manipulate this problem by moving all of my x's to the left side and all of my regular numbers to the right. I'm going to add 5 times log 10, 5 times log 10 there to both sides, eliminating it here on the left side. So we have 3x log 10 on the left. And I'm going to subtract, use a different color here. Let's go green. I'm going to subtract x log 7 from both sides. Now keeping in mind that these logarithms over here aren't actually the same. One's a log 7 and one's a log 10, so they're not like terms. So I'm just going to write it out like such. And when I do so, these are all gone, meaning all I have left on the right side is 5 log 10. Now what I did here is I basically just went about trying to get everything with an x on one side, everything with an x on one side, and everything else on the other. Cool. So now what I can do is I can actually turn these values, log 10 and log 7, into numbers. That'll be a little bit easier to work with at this point. So the logarithm of 10, let's just round it to the nearest 4 decimal places because that's what the directions ask of us. Sorry about that, I don't have my calculator up. So now log of 10 is 1, which makes sense. I don't know why I didn't think about that earlier. Well, why is it 1? Because what log of 10 is saying is log base 10 of 10, which is really saying 10 to what power equals 10, and the answer to that is 1. So really this whole thing, and silly me for not noticing that right off the bat, is 1. All right, minus x times log of 7. So let's use our calculator to evaluate what log of 7 is, and that's saying 10 to what power is 7. And so that's going to be a decimal, not even a whole number there. Log of 7 is going to be something smaller than 1. And sure enough, it is 0.8451 to the 4 decimal places. 0.8451. Sweet. And that is equal to 5 times log of 10. And we just said, oh, log of 10 is 1. So 5 times log 10 is synonymous to 5 times 1, and 5 times 1 is 5. Sweet. So now all we got to do is continue to work this down, and we have 3x times 1, aka 3x, minus 0.8451x equals 5. What we can do now is on the left side of our equation, combine like terms. 3 minus 0.8451 x is going to be 2.1549 x, and that's equal to 5. So now all I got to do is divide both sides by 2.1549. And once I do that division, x is going to be isolated. Move over here to the right. And let's see what 5 divided by 2.1549 is. 5 divided by 2.1549 is approximately 2.3203. Let's call this an approximation because it's rounded to approximately 2.3203 if my memory serves. Yep, there's our approximation for x, rounded to the nearest fourth decimal place.